Welcome back, guys. We are doing a two-part lesson up next here, and it's over relations and functions. And today is obviously part one of that. Now, we're going to see tables like this one at the right here in these next few lessons. These are familiar to you, hopefully. This specific table is talking about giraffes, and it's a list of some data here on a few giraffes, and it measures their height at a certain age. So realize that this table and this data here, if I'm like comparing two things and how they're related, this is just called a relation. And all a relation is, it's just a set of ordered pairs. And you guys are familiar with ordered pairs, so if I kind of wrote one out here, it's like x comma y. In a table, hopefully you know this, the x's are always on the left and the y's are always on the right. The x's come first because those are independent. So the age, it is what it is. Okay, this giraffe is a certain number of years old, and the height usually depends on your age. So we call that the dependent variable. I'm going to write that here. So x is independent and y is dependent. Ran a room that says dependent. So your height, it depends on how old you are. So usually for a giraffe, the older they are, the taller they are. Okay, so hopefully none of that's brand new to you. X on the left, y on the right. This is just a relation. So it's how the two things are related, and that's exactly what you can think of this as. A relation is just a relationship between x and y. Sounds fancy, but it's not. It's just how are x and y related. Now, realize that you can turn a table like this into a list of ordered pairs. So if I just took this first giraffe, it's 18 years old and it's 4.25 meters tall. If I just kind of group those together in an ordered pair, I would have this first ordered pair right here. The first number, that's still the ages, and the second number is still the heights, still x, still y. But realize that you could turn a table into a list of ordered pairs. Now, today we're going to be like learning some new terms. I'm guessing you maybe have never heard these before, but in a relation or some ordered pairs here, the x values, those have a name. It's called the domain. So I'm going to kind of list those here. Those are the x's, and we call those the domain. Again, sounds super fancy, but that's just the x values that I'm using in my relation here. So it's all the ages of the giraffes. So the y values then, those also have a name. We said those were the heights. We call the y's the range. Again, it sounds fancy, but domain is just the x values being used, and the range is just the y values being used. So if I see this example here, and they ask me to list the domain and list the range of the relation, just ordered pairs, I can do that pretty easily if I remember domain is x and range is y. Couple notes to make here. You list them from smallest to biggest, and you don't have to repeat. If there's like an x value used twice or a y value used twice, you don't have to write it twice. So let me show you what I mean here. So I know the domain's the x's. If I think about ordered pairs, x comes first, then y. So if I'm trying to list the x's, that's really just the first numbers in these ordered pairs here. So I'm going to circle them so I can kind of keep track of it all. But you've got 5 ordered pairs in this relation, and I just want to list out what are the x values that are being used. So smallest to biggest, I would go -3, comma, and you just list them with commas in between. -2, if you want to cross them off after you use them so you don't like leave anything out, that's not a bad idea. 0, and then see how 3 is used twice, I'm only going to write it once. I don't need to waste my time writing it twice. I'm just showing someone what x values are being used. So 3 is accounted for. A lot of times you'll see them like put I don't really know what they're called, but like brackets or like fancy parentheses, they'll put those around the domain and range. Okay, so the range is just the y values then, or the second number. So same thing. I like to maybe circle them so it kind of stands out a little bit better because there's tons of numbers going on here. And then I just list those from smallest to biggest. So -1 is the smallest. And then I got 0, 1, and see 2 is on there twice, but I'm only going to write it once because I've accounted for it. Okay, so that would be me listing the domain and the range. Pretty simple if you can remember which one's which. We keep it pretty basic in this class in Algebra 1 with listing domain and range, but when you go to Algebra 2, it gets a lot more in-depth and challenging. Now, the second part of today, so we're talking about relations and functions. A relation, like we said, is just a relationship between x and y. There are some relations that are specific enough that we call them a function. Now, a function is a relation, so it's a relationship between your x's and y's, and it gives exactly one y value to each x value. So what that means, if I came back to the giraffe data, it gives exactly one y value, so the right-hand side, to each x value. This is not a function because if I look at the age 18, so there were two giraffes that were 18 years old, they had different heights. Okay, a function just is going to have one specific height for each age. But I've got two heights, two y values for the age 18. So this is just not specific enough. This would not be a function because there's two y values listed under the same x value. Okay. In other words, and I know that's kind of like a little hard to wrap your mind around at first, but if you're asked if something is a function, you basically just need to know that x cannot be used more than once. Okay, so you just need to see if x repeats, it's not a function. Notice that in this example, this was not a function either because 3 was repeated. So there was like 2 was assigned to 3 and 0 was assigned to 3. So there were two y values to the same x value. If that happens, it's not a function. You just need to look and see if x is used more than once. If it is, not a function. And we'll practice that, so don't think that that has to make sense immediately. Okay, so one way is to look and see if x repeats. Another way to tell if a relation is a function is to look at the picture of the graph, which we're going to do that now. Okay, we use what's called the vertical line test when we're looking at the graph to say whether something's a function or not. So this is actually the same relation as the previous example. What I'm going to do though is I'm going to plot the points and show you how I would use this test to say that it was not a function. So if you forget how to plot points, remember an ordered pair, it's x and then y. The x value, that tells you left and right. Some of us maybe forget this. And then the y value tells you up and down. This is the first time we've plotted points in this class. Get ready, we've got lots of graphing coming up here. So if I want to plot the point 3, 0, you start at the origin in the middle, and it's positive 3, so that's going to be right. So I'm going to go right 3, and then it's 0. So I'm not going to go up or down. Also, this is not an ordered pair. Sorry. I made a mark at the origin. Don't do that, or if you did, erase it. So that's the first ordered pair, 3, 0. -2, 1. So you start in the middle, it's -2, so I'm going to go left 2 and then up 1. Okay, so left is negative, right is positive, up is positive, down is negative. -2, 1, I would go left 2, already did that one, 0, -1, so I would not go left or right because it's 0. I just want to go down 1. If it's negative, go down. Negative 3, 2 would be right there, and then 3, 2 would be right there. If you need help plotting points, ask me, okay? Now, vertical line test. Vertical lines go up and down, like that. So if you use the vertical line test, you can look to see if x repeats. Now, all you essentially have to do is draw a vertical line through each point on this graph. If one of your vertical lines goes through 2 points, like it did right here, that's not a function. And the reason that that's not a function is because there's 2 y values to the same x value. So the x value here is 3, and I've assigned that 2 y values, 2 and 0. Okay, so x is repeating. I can tell that if my vertical line hits 2 points, this is not a function. So sometimes a relation is just given to you by the graph. They don't tell you the ordered pairs or the table, but you could still answer whether it was a function or not, whether it was a specific relation, by using this vertical line test. You can do 2 things, you guys. You can either just like draw a bunch of vertical lines, and if every vertical line only goes through your graph 1 time, and the graph on this one was just that line, if every vertical line only touches the graph once, like it did here, then yes, that is a function. But look at the second one. So say just that vertical line right there. The circle is the graph. The vertical line I drew touched the circle twice. If that happens, it's not a function. Some people choose to just like draw their pencil and like take their pencil and like go across the graph. If you only touch this graph 1 time with your pencil, then you're good. Or you could draw a bunch of vertical lines. Doesn't matter. You're just looking to see, do my vertical lines hit the graph more than once? This one is good. Each vertical line only touches the graph, the u, 1 time, so this is a function. Okay, I want you guys to try saying yes or no here. And I'll check it when I check your notes. Okay, so we have learned that you can model a relation or a relationship between x and y a few different ways. You can use a table, like we had with the giraffes on the front. You can either list the ordered pairs, or you can look at the graph. Okay, lots of options. So there's a relationship table, there's a relationship with ordered pairs, or I can draw a graph to show a relation. Okay, you can also do one more thing to kind of show a relation, how x and y are related. You can draw something called a mapping diagram. All of these methods, you guys, are just used to show how x and y relate to one another. Okay, there's really not much more to it than that. The mapping diagrams, you'll see it in this unit. Beyond that, we won't really take the time to draw these a whole lot, but it's not a bad thing to learn. So here's a list of ordered pairs. So here's my relation, my x's and y's, and I want to make exactly that mapping diagram we just talked about. Here's what you would do. So you would list the domains, the x's, in the left-hand side, that box there, and you would list the ranges on the right-hand side in that box. So I'm going to do what I did on the front. I know the x's are the domains. Those are the first numbers. I'm going to go smallest to biggest. And I'm not going to write 4 twice because I don't have to. The ranges, those are the y values. The second numbers, well, lots of numbers here. Let's say they'd be 0, 1, 3, 4, 5. Okay, so I listed them just like I did on the front. The mapping part of this, though, don't forget to do. So in an example like this, you may not even have the ordered pairs listed out, but you do want to show someone like what x, what domain goes with what y. So you draw arrows to like map the x's onto the y's. So come back to your ordered pairs here. Here's what I would do. 3 goes with 5. So let's see. 3 maps on to 5. -2 goes with 1. So -2 goes with 1. 0 goes with 4. 4 goes with 0. 4 also goes with 3. So I'd have kind of 2 arrows coming out of that one. So that's called a mapping diagram. It just maps the x's onto the y's. Very fancy, very fun, I know. Now, at the bottom here though, and if I kind of think about this one before I get to that, if I didn't have the ordered pairs, I could look at this and say whether this was a function or not. And that's exactly what they want me to do. Determine whether it's a function. If it's a function, x can't repeat. I'm going to make a note of that again. That's the big thing to remember. It cannot repeat. X cannot repeat for it to be a function. So if I looked at this, I know the domain is the x's. I would see 4 being used twice. 4 goes to 0 and 4 goes to 3. So this is not a function. Okay, so if I look at these two examples here, and you're going to try the second one here. I want you to tell me yes or no, is this a function? This one, let's see, 11 goes to -2, 12 goes to -1, 3 goes to -2, 20 goes to 7. Now, it's okay that there's a range value being used twice. 11 goes to -2 and 13. The y can repeat. You just cannot repeat the x. Okay, so this one is okay though. This is a function because x does not repeat. Each domain only has one arrow coming off, so I'm good. And I want you guys to try the second one.